Section 5.1, quadratic functions. Now this section is going to be, we've talked about quadratic functions before, we've talked about factoring before, possibly briefly. We're going to focus more on kind of the graphing and the properties around what would make a parabola look a little bit different. So some terms that are helpful, we've seen x-intercepts before, we've seen y-intercepts before. Kind of the new terms is the axis of symmetry and the vertex. One kind of cool property of parabolas is regardless of what you do, if you move it, if you stretch it, or you shrink it, it still is symmetric about something. You could essentially fold it in half and it would match the other side of it. And so that thing that we could fold over is called the axis of symmetry. It kind of cuts the graph in half. And then the vertex is always going to be kind of the lowest point of the parabola or the highest point of the parabola. If we're doing applications questions, we talk about the vertex because it's the highest point that you would throw something before it kind of starts falling back to the ground. Now, this is general form. The most generic form of any quadratic is just if we have like 2x squared plus 3x plus 4. It has some advantage, but it's kind of its most generic form. There hasn't really been any factoring done to it or anything like that. And it's really hard to figure out where in the last slide that vertex is. I can't really know where that is by just looking at this equation. So we kind of bring in this new form of, okay, well, if I have something written like this, I get a lot of pieces of information about my quadratic. I get what my vertex is. It's h and k. And notice how it's going to be opposite of whatever's inside that function, just like we saw with transformations. But I get the vertex. If I have something in vertex form, I know exactly what the point of my vertex is. I can kind of get this into vertex form from general form, but other pieces of information is if I know what A is, I can know the direction that my graph is going, go up or down, and I can know kind of the stretch or the shrink. Okay, so now to get into how to specifically take something from general form, which doesn't have a whole lot of value, it has a couple of things that are nice, but into vertex form. And so how I do that is in order to identify my h is always going to be negative b over 2a from that general form. And then to find my k value, what I do is I take whatever that h is, that negative b over 2a, I put it into my original function, my original general form, and whatever that result is going to get me my k. A lot of notation, a lot of numbers flying around, letters flying around, I guess just letters flying around. So let's see it in practice. It's actually not too terrible of a process. So here's something in vertex, or not vertex form. This is general form. This is something I want to get into vertex form. And so I do that by finding my h. My h is negative b over 2a. Well, the b term is always what's in front of the x. The a term is always what's in front of the x squared. So I have negative 4 over 2 times 2, which is negative 4 over 4, which is, nicely enough, negative 1. Now I take that negative 1, I plug it back into my function, and I get, well, if I replace all of the x's with the negative 1s, get 2 times negative 1 squared plus 4 times negative 1 minus 9. Gets me 2 times 1 minus 4 minus 9 gets me negative 11. So that's my vertex. And then the only other thing that I need to know for vertex form is my a value. Well, I didn't really talk about how to find my a value in the last slide because it's so easy. My a value is already given to me if I have general form. It's the thing in front of my x squared. So I don't really have to do any additional work to find my a. But now I have my h, I have my k, I have my a. This is my vertex form. Now I just fill in the blanks. I put my h in, I put my k in, I put my a in. Well, the only thing that looks a little bit different is, yeah, my h was negative 1, so it's x minus negative 1, which becomes positive 1. Or you can always kind of think I'm going to flip my h sign when I put it into vertex form. And then everything else is as expected. A is 2 and k is negative 11. Now, another piece of information that we can get from vertex form, and I didn't really mention, is domain and range. Well, that's a little bit misleading. Domain is easy for any quadratic equation. That doesn't fall into case 1, case 2, or case 3 of my, doesn't fall into case 1 or case 2 of my domain. So it's case 3. It's all real numbers, or negative infinity to infinity. While the range is, well, it depends. If my a is positive, then my range is going to be the value of the k value of my vertex up to positive infinity. My parabola is going to be facing upwards. Or if my a is less than 0, then my range is negative infinity up to k. My parabola is going to be opening down. So let's see this in practice. I have f of x is equal to negative 4x squared plus 6x minus 7. Well, I already see my a is negative 4, and so my range is going to kind of be that second case. But we might be getting a little bit ahead of ourselves. So for starters, we need to find k. In order to find k, I find h first. My b is 6, my a is negative 4, so negative b over 2a becomes negative 6 over 2 times negative 4, which I repeated for some reason. And then if I simplify that out, I get 3 over 4. Now I plug in 3 over 4 into my original function. Yes, I have kind of some gross fractions flying around, but it's just a basic order of operations question. And so my first fraction, if I do negative 4 times 3/4 squared, I get negative 9 over 4. My second fraction is 18 over 4. And then I'm subtracting 7. Then I kind of spared you the steps, but I would have to go about maybe doing some fraction, adding a fraction, subtracting a fraction, or if you have a calculator, they can usually just find the fraction for you. And my k is negative 19 over 4. Now, in order to find my domain and my range, well, my domain is given. It's always negative infinity to infinity. That's not too hard. And my range is going to be, as I've mentioned, it's going to be the second case. So a is less than 0. So my range will be negative infinity up to my k, which I found. My negative infinity, or my k is negative 19 over 4. Great. So now I know that if I have vertex form, it's very easy to find my domain and my range. Finding minimum, maximum is very similar to finding the domain and range, well, more specifically the range. So we're going to have two cases just like we did with range. If a is less than 0, we're going to have an absolute maximum at h comma k. If a is greater than 0, we're going to have an absolute minimum at h comma k. So instead of doing another example, let's kind of look at the one we did on the previous slide. F of x is equal to negative 4x squared plus 6x minus 7. Well, we already found what our vertex was. Our h was 3/4. Our k was, well, it was negative 19 over 4. But our range was negative infinity up to negative 19 over 4. Now, if you're kind of decent with what range means, you could probably already glean on what the answer is going to be with those two pieces of information. But let's do our due diligence and kind of say, okay, our a is less than 0, it's negative 4, so I'm going to have an absolute maximum at my vertex. Well, my vertex is 3/4 comma negative 19/4, and so that is my maximum. You're either going to have a maximum or a minimum. You won't have both. So if a is less than 0, your vertex is going to be your max. If a is greater than 0, your vertex is going to be a minimum, and you don't have to do any more work. We want to be able to take a quadratic equation or a quadratic graph of an equation, graph of a quadratic equation. That's the thing we're going to try and find. So that's what we have here. We have a graph of a quadratic equation, and now we're going to try and find the actual equation of it, the actual function. Well, for starters, the vertex is usually pretty doable to find. If it's not, then it's probably not going to be a question on your test. It should be very straightforward what your vertex is. So in this case, my vertex is negative 1, 3. And now the next things we have to think about is, well, singular. I have to figure out what my a is. Okay, well, my a has to be negative. I know that. And I'm going to kind of use an additional point to really find the value of a. It could be, sure, it might be 1, but it could be 2. We could be stretching by a weird value. So what we do to find that is we take the equation of the vertex equation, we plug in our vertex, and then we try and find our a. We don't know what our a is. So we plug in our point, 0, 2, plug in 0 for x, 2 for f of x, and now we just try and solve for a. We do a little bit of algebra. So 0 plus 1 squared gets me 1, so 1 times a is a. So then I know 2 is equal to a plus 1, and a is equal to -1. So like I mentioned, kind of a bit of a mental logic check. My graph is upside down, so I probably should have a negative value of a. So my final answer is f of x is equal to -1 times x plus 1 squared plus 3. Now, even if it doesn't like explicitly tell you to find a, like sometimes maybe a graph a is just 1, which seems kind of silly to go through this whole process. You need to, because quite often that's not the case. And even if it is the case, you kind of have to justify your steps and say, oh, look, I plugged in my value or my additional point. I found a, it happens to be 1. And so this is my final answer. This is one of the most difficult word problems we're going to see. Yes, it is on WebWorks. Yes, I think historically this kind of rears its ugly head on the exam, and it's probably the hardest question on the exam. So all of that's to say, there's only really there's not a whole lot of variety of this type of question. It's going to be a maximum area, and yes, it might not be a fence, it might be a wall, but the process is almost exactly the same. And so it seems like we don't know how to do this problem. The question seems unrelated to quadratics. It says, I'm planning on building 3 sides of 3 side-by-side pens in a farm. I have 400 feet of fencing. What are the dimensions that maximize the area of my pen? So like I said, feels unrelated, but regardless, even if it seems that way, any type of difficult word problem that you may see, your first step is to draw some sort of picture. So I'm going to draw a picture with 3 different pens, and I'm going to say, okay, well, it's going to have a length and a width. So I'm going to label all of my widths as x, and then my length all the way across will be y. That will be all the way across on top as well. Okay, so I'm still kind of feeling my way through. Still doesn't seem like I would know how to solve this problem, but at least I have a picture now. And I'm told that I have 400 feet of fencing. Well, fencing seems like in this case, that's kind of the perimeter of my shape. And perimeter is a loose term. Usually it's only the outside of my function, outside of my shape. But all that's to say is that all of those variables, my 4x's and my 2y's, should add up to the total amount of fencing that I have. Otherwise, I wouldn't really be able to build my pen. So my perimeter, I put that in quotes, is 4x plus 2y. That's all of those variables added up. And now I also know, no might be in quotes as well, I also know that my area is length times width, or in this case, it's going to be x times y. That'll get me my total area of all of my big pen, which has 3 side-by-side pens. So area is equal to x times y. Now, I have 2 equations. I have 2 variables. Anytime this happens, it's bad. So what we try to do is we try to make it so that we only have 1 equation with 1 variable, and then that's usually solvable. So I'm going to, I don't know anything about my area, but I know my perimeter is 400, so I'm going to plug in 400 for p. And now I'm going to solve for a variable. I believe I solve for y, but you could also solve for x. So I'm going to solve for y. Subtract 4x over, I divide both sides by 2, I get 200 minus 2x is equal to y. Now I plug that into my area function, and now I have a is equal to x times 200 minus 2x. I'm going to simplify a little bit further. A is equal to negative 2x squared plus 200x. Now pause, think for a second. Have we seen something like that in this section? Ignore all the white noise, just that very last equation. We have. That's the general form of a quadratic. It looks weird. Yes, we're missing a C term. That's perfectly fine. You may have noticed when we're finding vertex form, we don't even talk about what that C is. So I'm going to take that quadratic. I'm going to find my vertex form, because if I know my vertex form, well, we already talked about how that will show me what my maximum value is. So I'm going to find my vertex form. My B is 200. and my a is -2, so I get -200 over -2 times 2, which is -200 over -4, which is 50. Well, if that's my maximum value, or part of my maximum value, that's the x value. That's my h. Now what I'm going to do is I'm going to take that 50, I'm going to plug it into my middle equation, well, the bottom middle equation, and that's going to get my other dimension, my kind of length times width. So if I plug in 50, I get 200 minus 2 times 50. Well, 2 times 50 is 100. 200 minus 100 gets me 100. And so those are my two dimensions. It's 100 feet by 500 feet. I should include units, so that should have 100 feet by 50 feet. I would lose points on a test if I wrote that answer. And then, as I believe I mentioned, if the question was asking for maximum area, which is kind of an interesting result, well, I would either find my k, or area is just length times width. I would multiply 100 times 50, so my area is 5,000 feet squared. I lose a lot of points on the test. Make sure you include units with your word problems. Hopefully I did that on this one. Okay. The height of a rock that has been thrown off of a cliff can be modeled by h of t is equal to -16t squared plus 96t plus 112, and I assume that's in feet. When will the maximum height happen? What is the maximum height, and when will the rock hit the ground? Okay, so really three different questions here, but they all revolve around, well, everything but the last one revolves around vertex form. So let's find our vertex form. It's going to be -b over 2a, so -96 over 2 times -16, -96 over -32, which is 3. And then in the context of the problem, that's seconds. That's my time. So that's how long it's going to take for it to reach a maximum height, or that's how long it's going to take. Now, in order to find the maximum height, well, that's going to be the k value. So to find my vertex, I'm going to plug in 3 into those spots, multiply through, and yeah, I included my units. I have 256 feet is the maximum height of the rock. Now, the last one, the first two are kind of like, okay, yeah, I see a quadratic. I probably need to find my vertex. That's the route I'm going to take. The last question, I kind of have to think for a little bit. It says, when will the rock hit the ground? Okay, maybe you could picture that on the graph. It's kind of be a parabola is flying up and then kind of falling down, hitting the ground. And now logically we have to think, okay, what's the height of a rock when it hits the ground? It's 0, right? The height would be 0. It's going to hit the ground. It's no longer off the ground at all. And so what I'm going to do is I'm going to plug in 0 for my h. And then, well, there's a lot of strategies we could use. We could use the quadratic formula. We could use the completing the square. We could use factoring. I think I use the quadratic formula. If I haven't shown the quadratic formula in this course, then use factoring. That's perfectly fine. We'll talk about the quadratic formula later, if that's the case. All of that aside, my answer is t is equal to -1 and 7. Okay, well, that's weird. It only should probably be hitting the ground once, unless maybe it skipped, but let's assume it doesn't skip. So we got to make sense of these answers. Well, the first answer is at negative time, so that probably doesn't make sense. So we're actually only going to use the second value. The rock will hit the ground in 7 seconds. That's the end of this section.